We have learned how to create a scatter plot. We've learned how to create a trend line that models that scatter plot. And then most recently, we've learned how to write an equation in slope-intercept form to say exactly what that trend line is and use that trend line to model data and make predictions. Trend lines model the general pattern of data, and because they are modeling relationships, they allow us to estimate unknown values. So let's take a look at our equation that we came up with in the last lesson, which was y equals 5x plus 55. And in that problem, our x, or independent variable, was our studied, and y was our test score. And let's ask ourselves a question. I want to predict the score for a student who studies for 4 hours. So in that lesson, what we learned is I can take the value of 4, which was hours, and substitute it into my equation. 5 times 4 is 20, so I'll have 20 plus 55, and 20 plus 55 is 75. So what that tells me is we predict a student who studies for 4 hours would make a score of 75. Trend lines and equations can be used to predict values of y for given values of x. It's important to remember that predictions are estimates, not exact values, so I don't expect that a student who studies for 4 hours will make exactly a 75, but it's a good prediction. I think they'll make about a 75. The slope describes the rate of change between the variables, and the slope tells us how much y changes when x increases by 1. If you recall our equation being y equals mx plus b, then in y equals 5x plus 55, you know that the slope is the value of 5. But 5 what? What is the context for 5? What it means is that for each additional hour studied, we predict that the person's test score is going to increase by about 5 points. It's important when we talk about slope that we always interpret it using the units of the variables. We don't ever want to just stop and say slope is 5. We always want to say 5 what? And usually whenever you're describing slope, you will use the word per. And here are some examples of units that we would use to describe slope. Things like miles per hour, dollars per item, points per hour studied. Slope usually has the word per in it because we are describing a rate of change between the variables. The second part of our equation is the y-intercept, interpreting the y-intercept, which we've learned is the predicted value of y when x equals 0. Again, looking at our equation, y equals 5x plus 55, the y-intercept is the value of b in y equals mx plus b, and in this equation it is 55, but 55 what? And the answer is points, 55 points, and it is the value of a test score for someone who studies for 0 hours. When x equals 0, and in this problem x is how long you study, if someone studies for 0 hours, the predicted test score would be 55. It's important to keep in mind that sometimes the intercept may not make sense in context, so predicting a score of 0 hours studied might not be realistic depending on the situation. Maybe we have some people who study for 0 hours, but it might not necessarily give us a realistic value. For example, what if our y-intercept had turned out to be a negative number in this case? Might not make sense for someone to have a negative test score. Or suppose the test was graded in such a way that the minimum score the teacher gave was a 60. Then maybe a y-intercept of 55 wouldn't make sense. So it's important to think about the y-intercept in context and make sure that it makes sense. And we'll talk about that more in just a minute. Finally, there are 2 types of predictions that we will make whenever we are using one of these linear models. One of these types of predictions is something called interpolation or interpolation. And that is whenever you predict within the range of data that we have collected. So for example, if my data includes study times from 1 to 6 hours, meaning I have collected data from students who have actually studied for 1 to 6 hours and got their test scores, and then I said predict what would happen if someone studied for 4 hours, that's interpolation. These predictions are pretty reliable because I am predicting within data that I've actually collected. The other kind of prediction is something called extrapolation. And extrapolation is whenever I go outside the range of data. Again, assuming I have collected data from students studying for 1 to 6 hours, and then I said, predict what the score would be for a student who studied for 12 hours. That might not be a reliable prediction because I'm asking you to answer a question based on a number that is outside the set of data that I have collected. And the farther away from my data set, meaning the farther away I get from the numbers in my table, the less reliable my data is. So let's talk about how to tell if your prediction is reasonable. Let's go back to our equation, y equals 5x plus 55, and let me ask you to substitute in the value x equals 30. So this is an extreme value because this is someone who studies for 30 hours in preparation for their test. So let's go ahead and replace the x with 30. So we have 5 times 30 plus 55, and 5 times 30 plus 55 is 205. So what this is telling me is a student who studies for 30 hours has a predicted score of 205. So this is an example of extrapolation because the most number of hours I had in my set of data was a student who studied for just a handful of hours. And now I am making a prediction far beyond that. I'm predicting for a student who studied 30 hours. And as a result, I come up with an answer that does not make sense. You cannot have a test score of 205 no matter how much you study. The highest test score you could get is 100. So 205 is outside the range of data. So it's important when we make these types of predictions that we consider the range of the data and also the context of the situation. Is it possible for us to have a score this high? And the answer is no. No, it is not. So when making predictions, consider both the range of the data and the context of the situation. So what have we learned? We've learned that trend lines allow us to do a few things. They allow us to make predictions. They allow us to interpret the slope as a rate of change, and we need to interpret it in context using a unit. And trend lines help us understand the relationships between variables. When we are making predictions, which is one of the things trend lines are really useful for, we need to make sure our predictions are, number one, within the data range when possible, and number two, make sure they are reasonable within context.